Hello everyone, Mr. P here, and today we are going to graph functions in factored form, specifically quadratic functions. Okay, we're going to graph quadratic functions in factored form, and these are the two examples we're going to get to today. Before we get to those though, we have to learn a little bit about standard form and factored form. Okay, so standard form is the one up top here. Standard form looks like this. When you have something like y equals ax squared plus bx plus c, this is a standard form trinomial, right? Where a, b, and c could be some type of coefficient or integer, right? -1, +7, -2. And then factored form, of course, we have our factors or our brackets, looks something like this. So y equals a, where a would be some kind of coefficient, or could be like a GCF or factor. And then you got your factors x minus r, x minus s, where again, r and s are some kind of number, some integer. Okay, so that's standard form and factored form. So to convert from one to the other, we need to know how to do that as well. So this first example here, the 4, x plus 4, x minus 3, currently this is in factored form, since you can see our coefficient and our two brackets are two factors, right? If we go back there, we can tell this is factored form. Okay, so right now it's in factored form. So FF factored form. And what we're going to do, we're going to expand this so we can get it into some other form, and we'll see what happens. So we're going to expand this one. We'll start with the brackets, and we'll save the 4 till after. Expand and simplify. So you're going to do x times x, you get x squared. X times -3, -3x. Then 4 times x, you get plus 4x. 4 times -3, you get -12. And let's simplify this first before we deal with that 4. So we can add our like terms of the x's there. -3 plus 4, we have one of them now. So you get 1 left over, x squared. You get plus 1x, so just x. And then -12. And then now let's multiply that 4 into this thing, okay? So we're gonna do 4 times x squared, get 4x squared. 4 times x, you get 4x. And then 4 times -12, you get -48, okay? And if you look at our answer, after we expanded, we started at factored form, right? We expanded and simplified. And now our answer is in standard form, right? SF, standard form, okay? We know it's standard form because there's no brackets. It's all out in the open. It's in descending order in terms of the exponents on our variables, right? It goes x squared, x and a number, right? 4x squared plus 4x minus the number 48. So we know if we want to go from factored form to standard form, all you need to do is expand and simplify. Okay, so factored form to standard form, you want to expand. And every time you say expand, it means expand and simplify. You always got to do both. Okay, let's check this other one here. 4x squared plus 4x minus 48. And right now it is in standard form, right? Hey, what do you know? It's the exact same answer from that one. So we're going to factor this thing. Okay, so we're going to take out a 4 first, common factor. 4 will be left with x squared plus x minus 12. So now we have a simple trinomial here that we can keep factoring. So we need two numbers to add to 1 that multiply to -12. That is going to be 4 and -3. So now we can keep our 4 on the outside. And our two answers are going to go x plus 4 and x minus 3. Okay, and this is our factored answer. And what you know, this looks like factored form, right? It looks exactly like this form down here, factored. Okay, so this time we started off in standard form, SF, and we've literally factored it to get to factored form. Okay, so now to go from standard form to factored form, all we gotta do is factor. Okay, so two simple rules, but now we know how to do that, okay? So standard form to factored form, you factor it. Factored form to standard form, you expand. Now let's get into the real meat of this lesson here, okay? So our goal is to graph this quadratic right here. Y equals x squared plus 2x minus 35. However, we cannot graph it until it is in factored form, okay? So since we're given this one in standard form, we're gonna start by factoring this thing to get it into factored form, right? That's the idea of today, right? To graph it in factored form. So let's get into factored form and factor this thing. X squared plus 2x minus 35. This is a simple trinomial. So we just need two numbers to add to 2 that multiplies to negative 35. And those two numbers will be positive 7 and negative 5. So we can go ahead and just put that in our factors here. So x plus 7 and x minus 5. Okay? And to graph this thing, directly from our factors, we can determine what our x-intercepts will be. So our x-intercepts are going to be the numbers from our factors, but with an opposite sign. All right, so the first one, since this is a plus 7 inside of our bracket there, our factor, our x-intercept will actually be the opposite of that, negative 7. So we're going to say x equals negative 7. And from the second bracket, the x minus 5, that's going to give us an x-intercept of positive 5. Okay? So now we can start graphing this thing, right? That's our goal, to graph this. We know what our x-intercepts are going to be. So x-intercepts, this is not going to be the scale. If you did this on your own Cartesian plane, it would be, but I'm just going to do a rough sketch here of where these points would be. So if this is the x-axis, this is the y-axis, the x value of negative 7 would be somewhere over here, let's say. Let's say that's negative 7. So that's going to be our x-intercept on that side, right? It touches the x-axis at negative 7 for x. And then our second x-intercept is going to be at positive 5 for x. So the positives will be on the right. So somewhere approximately there will be positive 5. Again, it'd be more accurate if you had graph paper or a grid. You'll see why in a moment why I'm not doing it on a grid. Okay, so there's our two x-intercepts. So that's a huge part of our graph right there. But we need to complete the rest of it. Okay, so now what we're going to do, we need to find the vertex. And before we find the vertex, we need to find the axis of symmetry, which is where that vertex will occur on the x-axis. So since we know that a quadratic function is symmetrical on either side of the vertex, that basically tells us that our vertex will end up being directly in the middle of our two x-intercepts, right? Because it'll be symmetrical among from the vertex. So that means if we find the average between our two x-intercepts, we can find the x location of where the vertex will be. In other words, we can find the axis of symmetry. So we're going to do that right now. And the equation we use for that is x equals r plus s divided by 2, where r and s are basically your intercepts. So r could be the negative 7, s could be the 5, but you can flip them around really. You're just adding them together. Okay, so we're going to add these together. So x equals r, let's say negative 7, plus 5, divided by 2. So now let's solve this thing. So negative 7 plus 5 is going to be negative 2. Divided by 2 is going to give us a value of negative 1. Okay, so that means our AOS, our axis of symmetry, is going to occur at negative 1. So I actually drew it in a pretty good spot there. Okay, so we know our vertex will occur somewhere on that axis of symmetry. We just don't know how high yet. So to determine how high, what we can do now, since we know our vertex will be at when x is negative 1, we can sub that value in for x into one of our original equations, either the original one or even the factored one. Either or will give us the correct answer. Usually the factored one is easier to solve, but either or will work. So I'm going to call it function notation now, just so you guys see it. I'm going to sub in negative 1 into the factored form. Okay, so that's going to be Instead of x plus 7, we're going to get negative 1 plus 7. And multiply that by, instead of x minus 5, we get negative 1 minus 5. Okay, now let's solve this thing. So f of negative 1 equals negative 1 plus 7 is 6. And then negative 1 take away 5 is going to be negative 6. So last step here, when we multiply this, 6 times negative 6, we get negative 36. And that is going to be our y value of our vertex, right? Since we found that the x value of the vertex is negative 1, and we sub that x value into the equation to find what the y value would be, we now found that the y value of that vertex would be negative 36. So if we combine 2 and 2 together, that means our vertex will be at the coordinate x comma y, but the x value is negative 1, and the y value is negative 36. So now you can see why I didn't do this on a Cartesian plane, because this is going to be really low. So if we plot this point, negative 1, of course, is on our axis of symmetry. Negative 36 would be somewhere way down here, wherever that ends up being at negative 36. So now we know where our vertex is, right? We have our vertex and we have our two x-intercepts. So now just to finish this thing off, we are going to complete our curve through our points and our arrows. And we know it has to open up because our vertex is below our two x-intercepts, and it has to go through both of them. So it has to end up opening up like that. Okay, so that is how we graph in factored form here. We're going to do one more, and this next one's going to be a little bit more challenging, dealing with some fractions. Okay, so we're going to graph f of x equals 2x squared minus 9x minus 18. And I might need 2 pages to finish this one off. Okay, so first thing, this is in standard form. So first thing we got to do is get this into factored form by factoring it. So this, you try to take out a 2 in common factor, you cannot do that. So we're going to have to factor using complex trinomial. So we need 2 numbers to add to negative 9, and multiplies to whatever 2 times negative 18 is. 2 times negative 18 is going to be negative 36. So numbers that work would be negative 12 and positive 3. That'll work. Okay, so we're going to go f of x equals 2x squared negative 12x plus 3x minus 18. Okay, then we want to slice this thing in half right after the second term there. Common factor both sides. So on the left, we can take out a 2x, and we'll be left with x minus 6. And on the right, we can take out a plus 3, and we'll also be left with x minus 6. Okay, so now when we fully factor this thing, we will get x minus 6, 2x plus 3. Okay, so now we can identify our x-intercepts. Okay, so x-intercepts, remember we flip the numbers from our factors here. So the first one is negative 6. So we're going to get an x-intercept at positive 6. And the second one, we're going to flip the plus 3 into a negative 3. But one more step on this one. Since there is a 2 attached to the x value, we have to technically divide this negative 3 by 2. So whenever that happens, make sure you get that fraction type of x-intercept. So just a side random example. Let's just say we had in brackets here 3x minus 4. Our x-intercept for that one would be x equals positive 4. Start with the 4, right? You just flip the sign, but it would be over the 3. Okay? So just a side note, just to show you guys how to do that. Okay? So those are our x-intercepts. And if you're stuck on plotting this one, negative 3 over 2, you can shove it into a calculator just to get the decimal value, and that'll help you determine what your x-intercept would look like. Okay, but if you do 3 over 2 you should get negative 1.5. So we can plot those x-intercepts here. So let's start with that. Let's actually go up here. So just gonna be a super rough sketch for now. We're gonna need more pages here. So x is positive 6, so that would be an x-intercept somewhere over here. Let's say that's positive 6 for x. And negative 3 over 2 would become negative 1.5. So negative 1.5 would be somewhere over here in the negatives, negative 1.5. So let's just draw our x-intercept there for now. So that's kind of where we're at right now, right? So now we need to find the axis of symmetry, which is going to end up being directly the average in between those values, right? Because a quadratic is symmetrical around the vertex. So now we need to do that same equation, x equals r plus s divided by 2. We're going to do that on the next page here. Okay, so x equals r plus s divided by 2. Okay, and remember our x-intercepts were 6 and negative 3 over 2. So we're going to go x equals 6 plus negative 3 over 2. And this is where it gets a little bit weird. Okay, and then we're going to divide this whole thing by 2. Okay, so the 6, I'm going to put it over 1 just so it's in fraction mode, because we're going to have to add it to the other fraction there. And since we need the same denominator to add it to negative 3 over 2, we're going to multiply it by 2 times 2. And at the same time, since we're adding a negative here, that's going to be the same as just subtracting. So we're going to make all those changes in this one step here. Okay, so the first fraction, when we multiply it by 2 and 2, we get 12 up top. All right, 6 times 2 is 12. And on the bottom, 1 times 2 is 2. And then the plus minus in the middle becomes just minus. And then the second fraction is now just 3 over 2. And this whole thing is over 2. So now we can subtract up top. 12 take away 3. We're going to get 9 over 2. So x equals 9 over 2 all over 2 still. And again, this, whenever a fraction looks like this, it looks super scary, but all it means is 9 over 2 divided by 2. So sometimes it helps to rewrite that out the other way. So all it means is x equals 9 over 2 divided by 2. And when you see it like that, it's much easier. So now we can turn the second 2 into a fraction by putting it over 1. And you know, dividing fractions, you flip or get the reciprocal of the second fraction. And then when you do that, it becomes multiplying. So the first fraction stays, 9 over 2 turns into multiplying, and then we flip the second one. Now it becomes 1 over 2 instead of 2 over 1. And multiplying, you just multiply across. So 9 times 1 up top is going to be 9. 2 times 2 on the bottom is going to be 4. Okay, and this is going to be our x value of the vertex, or the axis of symmetry, however you want to think of it. Okay, and if you want to, you can put this in your calculator. 9 divided by 4, it'll give you 2.25, just to kind of guide your graph. So now our axis of symmetry will be at positive 2.25. Okay, so that dotted axis of symmetry right here is x equals technically 9 over 4, which is basically positive 2.25. Okay, so now we need to find the y value of the vertex. And just like the first example we did, once you find the x value, to find the y value, you just sub this into any of your original equations, either the very original one or your factored one, and then you just solve to find your y value. Okay, so I'm going to sub it into the factored one. Okay, and I'm going to need to do this on a new page as well. Okay, so we're going to go f of 9 over 4, and you have to do this in fractions the whole time, which is a little bit annoying, but you guys can do it. So our equation was x minus 6. So instead of x minus 6, it's going to be 9 over 4 minus 6. And then the second factor, it was 2x plus 3. So that's going to look like 2 multiplied by 9 over 4 plus 3. Right? So it just replaces my x's with 9 over 4 there and 9 over 4 there. So now we got to clean this up, which is going to be a lot of fraction work, and that's okay. Just go slowly step by step. So in the first bracket, we need to subtract these. So we need to make this a fraction. And second bracket, we're going to need to add those. Before we do that, though, we need to multiply this 2, which is technically a 2 over 1, into the 9 over 4 in that second bracket. So 2 times 9 and 1 times 4. We'll do that first, and we're not going to change anything else. So 2 times 9, you get 18 up top. 1 times 4, you get 4. Okay, so I did that first. And now in my first bracket, we have a 9 over 4 here. That's fine. And the second fraction is over 1, but we want it to be over 4. So we're going to multiply that by 4 and this by 4. So 6 times 4 is going to give us 24 up top. And then, of course, we get 4 on the bottom. And then second bracket, we want this one to be a 4, so it matches up with the 18 over 4 in our next stage. So we're also going to multiply this by 4, and whatever you do to the top, and you do to the bottom, or vice versa. So 3 times 4 gives us, and it's going to be plus because there's a plus. 3 times 4, we get 12. 1 times 4, we get 4. So now we're rocking here. Now all of our fractions have the same denominators. And of course, the function notation here just stays. Okay, so 9 minus 24 on the first fraction, that's going to give us negative 15, and the denominator stays as 4. And the second fraction, 18 plus the 12, that's going to give us 30 up top and still over 4. And again, the function notation, just need to write it through, f of 9 over 4. And last step here almost, so now we were multiplying. So multiply our tops together, and then separately multiply your denominators together. And that will give us, so negative 15 times 30 will give us negative 450. And our denominator, 4 times 4, of course, is 16. And this fraction can be reduced. Looks like we can divide the top and bottom by 2, just to clean it up a bit. It's still going to be a big fraction, but that's okay. We'll get negative 225 up top and 8 on the bottom. Okay, so remember, what we were doing here, we were solving for the y value of the vertex. Okay, so now we put our vertex together. The x value we found already, right? The x value was 9 over 4. So it's going to go 9 over 4. And then the y value is now a negative 225 over 8. Okay, so to find where this goes on your graph, you might need to convert it to a decimal first. Okay, so 225 negative over 8 is going to be about 28. Negative 28.125, and then 9 over 4 we already did is 2.25. So a little bit decimally, but we can plot this vertex. So approximately 2 for x and negative 28 for y. So we go here. So 2 for x, we already kind of found it, right, on our axis of symmetry here. And if we go 28, and that's negative, right? So negative 28 for y, a negative 28 y value would be somewhere way down here. Let's say that's negative 28 for y. And then, of course, it'd be on that axis of symmetry that we found there at x is 9 over 4, or 2.25. So last step, just finish your curve and your arrows, and you're done. Okay, so the steps from both examples are identical, right? First, you factor your equation. Then you determine your x-intercepts by getting the flipped version of your numbers from your factors. Then you can graph your x-intercepts. Then to find your axis of symmetry, or the x value of your vertex, you need to find the average of those x-intercepts. So basically add them together, divide it by 2. Then you get the x value of that vertex. Then to get the y value of the vertex, all you're going to do is sub in that x value of the vertex into your original equation or your factored equation. And once you calculate that out, you'll end up with the y value of the vertex, which you can then plot to complete your quadratic here. Okay, that is it for this one, guys.